In this video, we're going to take a look at another type of scheduling. This is called the earliest deadline first approach. So the idea here is instead of associating some kind of permanent priority with the process, what instead we'll say is that the process with kind of the nearest deadline, that's the one we'll run first. Okay, earliest deadline first. So we have here some sample processes here, right? So we have basically our P1 and our P2. To annotate these for a minute, this over here is going to be my basically my burst time, 25, 35, and then these two are basically going to be my period and my deadline. In this case, we're just going to assume they're the same because it makes life a little bit easier for us. They don't have to be, but it just for the sake of discussion. So I have those two processes running. What happens? Well, essentially what you do, right, is you just look at what you have available and you say, okay, who has the nearest deadline? Well, in this case, right, basically when we start up, right, P1 has the nearest deadline, has deadline 50 versus P2 has deadline 80. And so we'll choose to run that. And you can see it's in our diagram over here, right? So P1 is the initial thing that runs. So P1 runs for a little bit, right? Eventually it completes. So the deadline that P1 was up against is basically this one over here. So this is basically our P's are up here, right? So P1's first deadline is over here, its second one is over here, its third one is over here, right? And then over here we have basically I have two deadlines for P2 in the graphic here, right? Actually, I could do a little bit better there. Our two deadlines for P2 over here. And we basically look and say, okay, you know what, this one over here, right, my P1, that's a lot closer to the start than, you know, P2's, so that'll be the one that I use. So erasing that stuff for a second. Let's say we run P1, right, it completes, then we run P2. Right, that's the one now that has the next deadline, right, it has deadline at 80. And so then P2 runs, right, takes up 35 units of time, runs for a while, right, ends up, you know, completing somewhere over here. It completes. We're done, right, and at that point, right, we basically have to switch back to doing P1. In this case, right, we look at the deadlines again, right, P1's next deadline is this one over here, P2's next deadline is this one over here, right, well, we pick the process that has the nearer deadline, and then make P1 go, right, so that gives us this instantiation there, right. Then after that, right, we basically have to jump back over to P2 because P2, right, that one all of a sudden has kind of, you know, it needs to do work, and then it also has the kind of the nearest deadline, and so on and so forth. Again, the idea, right, is that somehow every time you pick something, you're just picking whatever has the nearest deadline. The idea here is that if we're always picking the thing that has the nearest deadline, we're basically going to be making progress towards what's most likely to mess us up, right? We mess up if we don't hit a deadline. And so if we're constantly looking and trying to you know, run the thing that has a close deadline, well, then we're basically trying to avoid hitting that deadline, right? So there's some sort of an intuition there. And in general, this gets to something that's, you know, near optimal. So it's a pretty good way to go. So there are kind of some nice things here, right, about this general scheme, right? One thing is that the processes don't necessarily have to be periodic. The assumption behind the scenes is that, you know, for every given process, you're basically going to assume that you have, you know, burst time and then the deadline, right? So maybe it happens, you know, only, you know, once, right? We don't really know about the period. That's fine. We just know that it, you know, has this deadline. And we can handle it here, right? It'll kind of just slot in, right? When we're picking what we want to run first, that's just going to be one that's fair game for us to pick. Another third advantage is because it doesn't assume that the processes are periodic, is that you can kind of have a process, right, P1, that takes maybe different times each time it runs, right? So it could take, you know, 20 the first burst, 30 the next burst, 20 the second burst, right? Normally if we had a purely periodic system, we'd be obligated for that process to require the same amount of time every single time we ran it. But in this case, right, we support, you know, even, you know, non-periodic stuff, so it's natural to say, oh, periodic stuff that varies basically in the amount of time it uses, that'll be fair game as well. So it is a little bit more flexible than the other algorithm we've seen. Drawbacks, the main drawback here is simply that it's sort of a, well, it's nice in terms of it being like an online algorithm, right, a live algorithm, that's nice. But the issue is somehow, is that you can't really tell in advance whether or not things will work out. Now, if you have something that's kind of like a rate monotonic scheduling setup, right, basically the idea there is that we can kind of look and say, oh, hey, you know, how much CPU utilization do we have, you know, how many things do I have running, and then from that actually be able to say, oh, hey, will this thing work or not, right? Without having to run it, without having to simulate it, we can actually make that call in advance. We can do that statically. That was basically a static scheduling scheme. This, though, is a dynamic scheduling scheme, right? It's a live algorithm. And so here, right, we can't do that, right? We can't look into the future and know this thing is always going to work. So even though it is going to be an optimal answer, depending on what processes we ask to run, well, then there might be an issue, right? There might be an issue where, you know, we don't have enough time, right? And then things, you know, don't hit their deadlines and we get into trouble. So that's a primary disadvantage, right? We can't tell about that stuff in advance, right? Using the earliest deadline first scheme.